Hello friends, today we are going to discuss Kadane's algorithm. Uh, so the problem statement is actually to find the maximum sum of contiguous subarray. Uh, so given an array, we have to find the contiguous subarray which has the maximum sum. So if you see, this particular array has the sum of 4 plus 2 6, so the sum is 6. So this is the maximum, so this is the maximum sum of contiguous subarray from a given subarray. So how do we solve it? So one brute for is, starting from each element we go and find all the possible subarrays. So first case will be, let's say if it is -2, second is -2 1, then is -2 1 and 3, and so on, right? Similarly, when we say 1, so what are the subarray possible? So 1, then 1 minus 3, then 1 minus 3 4, and so on. So this we have to do it till end for all numbers. So what will be the time complexity? So that's for every element we go and find all possible subarrays. So it's n into n, so on square, right? So how to do it in a better way? So what we do is, just give me a second. Yeah, so now how to do it for the Kadane's algorithm. In Kadane's algorithm, we calculate the sum of every possible subarray till the particular element. So if I talk about, let's say, if I let's say talk about, so if I talk about maybe this element, so we talk about all the possible arrays ending till this point. If I talk about so this is 0 1 2 3 4 5 6 7 8. So if I talk about array 6, then I am talking about what is the maximum sum possible till this point, right? So now how do we do it? So let's say I'm talking about 4, right? So what are the possible arrays? -5 4 1 -5 4 and till the full array, right? And then what is the, out of these, what is the maximum sum possible, right? So let's consider array let's consider array 4 and array 5, right? So array 4, what is the maximum, all the possible subarray ending with that 4, ending with 4, right? So -1 this, -3 4 -1, 1 -3 4 -1, 2 -2 1 -3 4 -1. And what are the sum we are getting? So this is -1, this is +3, this is 0, this is 1, this is -1, right? And what is the maximum sum? So 3. So at array 4, what is the maximum sum we got? Was 3, right? Similarly, if we have to do it for array 5, which is 2, right? So how does it happen? I'm gonna write this particular, so I have 2, okay. First I'm gonna copy all the 2, and now what is the possible array? So actually if you see 2, then -1 4 -1 -3 4 -1 1 -3 4 -1. So these are the possible array ending at this particular element. And if you see, and let's see the sum also, right? This is 2, this is 1, this is 5, this is 2, this is 3, this is 1, right? So if you see, for the subarray ending at array 4, we have already calculated in the previous part, right? If we see this part, this was already calculated. So array 5 is the one which is new. And if you see, so we have already calculated the subarray ending at a0 array 4, right? So actually now we are just adding this new element. And so what will be the maximum sum? Will be something like, so let's say maximum sum possible at a particular index will be maximum sum possible on -1 plus the new element, right? Array I. And we have to choose a max between these two and array I. So it could be that the maximum sum was in negative and we add a new element which is still negative, and then number itself was positive. So we have to choose a max between these two, right? Is it like, so it's something like max at I is equal to max of array I or array I plus max at I minus 1. So this is Kadane's algorithm. So I think we are done. So what's the time complexity of Kadane's algorithm? So at every index, I'm calculating the max, and for the next element, I'm just dependent on the previous answer. So actually, the time complexity is O(n). So now let's go to the code walkthrough of this question. So let's get to the code of Kadane's algorithm, which is for the largest sum contiguous subarray. So what we have to do, first of all, we need to variable to keep track of maximum sum so far, which starts from 0, and we also want to have maximum local maximum sum. So let's name it like this. Okay, now what we have to do, we go and loop over each element, and so at this point my local max sum will be the previous local max sum plus the current element. So if so far, let's say this check is just to make it more optimized. So if the sum so far is less, if it is negative, we can actually make the max sum so far, sorry, the local max sum so far to 0. So if, right, so that if the sum became negative, we don't need to do we don't need to count it, we can actually make it a 0. Else if the max sum so far is less than the current local max, then my max so far becomes local max, and that's it, sum so far. So I'm ready with the code. So I've already written the test case for this one, which is this. So let's run the test cases. I'll show you the test cases as well. So okay, all three test cases pass. So when I have a normal array, when I have all ascending, so or all positive number, then the maximum subarray sum is actually sum of all numbers. This one is all negative, so maximum subarray is actually 0. And yeah, and I also have written a benchmark for this, so let's see how does it perform. So as you know, the time complexity of Kadane's algorithm is O(n), so you can see the benchmark here, it is 2.14 nanosecond per operation, so quite fast. And my benchmark data was actually 1000 elements, so I have stored 1000 elements and I'm running on it. Okay, so I'm done with the problem statement. See you until my next video. Bye bye.